Latest innovations in artificial intelligence are already anticipating how we will live and interact with technology in the next 5 years. The future scenarios of AI and the impact on our life were illustrated by Eric Schmidt during a chat at the Collision Conference 2022. Schmidt was Google's chief executive officer from 2001 to 2011 and had a key role in taking the company from a startup to arguably the most important technology company on the planet. Currently, Schmidt consults with different organizations, including the US Department of Defense, and invests in philanthropic initiatives and startups through his own company, Schmidt Futures. Here is what we should expect in the next 5 years and beyond.
Well, if you look, the biggest thing, 10 years ago when I was here a lot, the big story out of Canada and the United States was imaging. And in particular, the fact that vision, through things like ImageNet and others, would become better on computers than for humans. So if vision is better, that means doctors are better if they use a computer, cars should drive themselves, and all of that. That was the last cycle. The current cycle is really composed of two. One is that scientists are beginning to look at it as the following. I have an input function and an output function, and I don't understand, inputs and outputs, and I don't understand the function that causes the inputs to the outputs. Technically, it's a multi-dimensional space of high complexity, and I'd like to understand it at a lower level of complexity. Those inventions at a technical level are delivering enormous gains in biology, chemistry, medicine, drug treatment, material science, and things like that. And the other one are large language models. These large language models, which started with the breakthrough of something called GPT-3, appear to be conversational, and they're different from anything else we've ever done, because what you do is you have it look, and it learns everything it can, and then you figure out what it knows. And these systems today, now we update to this year, if you look at the Palm system out of Google, which was previewed a few weeks ago, the Palm system can actually translate computer languages to others without having been given specific examples. There's some kind of intrinsic knowledge representation that these deep learning models are getting that is very, very powerful. If you assume that that will continue, and since there's billions of dollars being raised to do that, you're going to see a bunch of stuff. One of the things you're going to see is what is called multimodal, where you go from text to speech and video seamlessly. They're all treated the same. And the second thing you're going to see is conversation, which is what the sentient question was really about. The ability to converse and also have this description with all the world's knowledge is very powerful. But there's one more trick, and that trick is called generative design. If you can study something, if you can predict a function, if you can use transformers to predict the next word, which is how all this started, you can also generate new things. And if you want to see something fun, look at DALL-E 2, which was released again by OpenAI about a month ago. My favorite example with DALL-E 2 is, show me a picture of two baby dinosaurs with backpacks going to kindergarten on their first day. And it produces a picture of two little dinosaurs going up the steps into kindergarten with their backpacks and smiling. How did it know that dinosaurs smile on the first day of school? It learned it somehow. That's very powerful. I'm quite sure that in the next 5 years, you'll be able to do two things. One is you'll be able to have your own AI second self, in the sense that you'll have a system that will watch you, that you can train it, it can speak like you, and it can sort of represent you within limits in certain situations. And the second is that you're going to have a very powerful AI assistant which will give you advice. This is a good person, this is a bad person, this is where you should go. Yes, Eric, you should go to Canada today, and yes, you should not tell that story because it's not a very good story. I'm sure that will happen. Where's the limit? And there's always a limit to technology. Most people now believe that these systems have trouble with common facts. They don't have a notion of time. They are brittle. They're easily attacked in adversarial ways. All of those issues have got to get addressed. If they're addressed, then you're going to have systems which are human-like but not identical to humans as our peer intelligences. And when I say they're human-like, I mean you'll say, boy, that thing is smart. But this is really important. They're not emulating human intelligence. If I think about it, you and I have known each other for a long time, I can roughly imagine how you think. You're human, you get up in the morning, you have an educational background, you speak English, we're here together, we're here in physical space. Imagine I have a computer over here. I have no concept of its theory of mind. I have no idea, can it flip to be evil? Can it invent something new that would hurt me? I'm always going to be worried that that box over there has some emergent behavior that no one has seen yet. Now, why am I focused on emergent behavior? Because the systems are learning, right? And they're not just trained to a static outcome. They're continuously learning. What happens if it learns something which is structurally wrong and it's in some important aspect of my life? And that's where I think the issues will be. I think it's important for computer scientists like me to start by acknowledging that we're not normal and not everyone behaves exactly the way a computer scientist does. And my observation in my now 45 years of doing this is computer scientists tend to think that everyone's the same, just like them, and they build tools for themselves. And if you look at social media as an example, I don't think anyone quite understood how the subgroups within social media would get weaponized around particular issues and so forth by any group. I'm not making a political statement here. So what I worry about is that these systems are going to change the way our human experience is. That the oracles and I mean that in a non-company sense, the oracles, the leaders, the mentors that we all have who are human and we have a theory of mind of who they are, what happens when my best friend is not a human but one of these boxes? What happens when my best friend, and I'm talking about, let's say teenage kids, teenage boy or whatever, and the teenage boy and the best friend says, I have a secret. And the kid goes, well, tell me the secret. And the secret is false. It's racist or abusive or not correct. And the kid doesn't tell the parents don't correct and throw the box out, and off you go. I am very worried that at global scale, this will change the way we experience our daily lives. It's already hard enough with everyone being connected, but when you've got these non-sentient but emergent behavior generative design systems, it's going to be a pretty rough case. You're going to be more paranoid than you are now because you're not going to know what it's going to do. And Dr. Kissinger and I wrote the Age of AI book to basically say now is the time to have the debates over values before we start deploying these systems at millions of people scale. Another example, in biology, it's pretty clear that the databases of how biology works are going to get built in the next 10, 15 years. I'm involved in funding a number of these efforts. They're fantastic, fantastic things. These have enormous implications, as I mentioned, for health, and it's all good. Except if an evil person takes open source AI, takes those databases, and uses it to generate bad viruses. Now you sit there and you go, how likely is this? I'll give you the numbers. There are about 600 companies that if you send them a digital file, they will send you, in the equivalent of Federal Express, something alive. Now, they today, by custom, not by rule, but by custom, check to make sure you're not making small box. We're going to have to think about what are the limits of what you can get manufactured in biology. I'll give you another example. I worked with the military for 5 years, and the military has a notion of proportional response and human in the loop. So here we are, and where the time compression, the military calls it the OODA loop, observe, orient, basically describe, and then action. The OODA loop is too fast for human decision making. So in cyber attacks, for example, the attack and the war, the attack and the response are faster than human decision times. We don't have a rule for what is a proportional response. I'll give you an example. Maybe the proportional response should be not in such a way that it doesn't amplify the conflict. So if you punch me, which you wouldn't do, I would respond with the same level force punch, not less and not more. That's an example of a stable game theoretic outcome. There are so many examples where we literally don't have the people, we don't have the conversations, and we don't have the agreement on how to handle this. And the reason I'm calling the alarm right now is I know it's going to happen because we've seen it with previous technologies. In the 1950s, all of the things that have caused us to be alive today, mutually assured destruction, containment, all of those, were invented in the 50s after the horror of the invention of nuclear bombs. And the reason they haven't been used since is because we came up with some workable agreements among people who don't even like each other.
There's some optimism in your notion that we could have rules and people will follow them. How do you address that? I mean, I don't know. I sort of see maybe the AI can follow rules, but humans will do human messy things.
Well, you want to distinguish between nation state and terrorists. So I'm going to take the presumption that nations have a self-interest in self-perpetuation. In other words, that they're not criminally evil and they're not trying to destroy themselves. People who are experts in this would give me examples where I'm wrong. So for purposes of argument, let's assume that even North Korea will follow basic self-interested principles. If that's the case, then the way you do the negotiation is you say, can we both agree on, for example, a no surprises rule? I'm not going to surprise you, and if I do, I apologize, and I'll warn you off the cliff. Another example is that when rockets are launched out of a country, the country tells the other countries they're going to launch the rocket, and the other countries use that to fine-tune their monitoring systems to make sure they know where the rocket goes. Because we don't want random rockets being launched with terrible weapons on top of them without thinking about it and having a response. So this notion of what is the proportional response, what is appropriate notice, and the other one that's important is bans on automatic weapon systems. I was part of a team and the chairman of a commission for the Congress where we looked at this. You don't want computers making the decision to launch an attack. It's just too dangerous. Now, again, it's obvious when I say this, Canada and the US would certainly agree. We agree on pretty much everything. Would China agree with that? Would Russia agree with that? I discovered one fact, by the way, that we have a rule in the US that nuclear weapons can only be launched by the President of the United States. Such a rule does not exist in China and in Russia, right? So we don't even have the basic rules in place. We've got to get on this right now. So on the optimistic side, if you're in a business, you need to be using learning in your algorithm. So I define AI as a system that is learning. Now, if you're building a system that is tactical and there's no learning, you're going to be beaten by somebody who's built a system that does what you're doing, but is also learning. Now, the learning stuff, you can do it on top of TensorFlow, JAX, PyTorch. There's now powerful libraries. All the cloud providers have libraries and so forth that you can build on top of. But the key scarcity is people who can build the learning back end for whatever it is you're trying to do. So I would focus on that. The best models have a situation where you essentially have a server, you have iOS or Android clients, and what happens is you're busy accumulating data, and then the back end learns something about it. And then there's emergent behavior that's useful. So all of a sudden, if enough people crowdsource, we discover what parties are the most important, what software is the most important, and that kind of stuff. I think that's number one. I think that number two, I would say, is that the large language models are really powerful, but not businesses yet. And if I were you, for each one of your startups, each one of the technology platforms, I have an idea of how I could use a question and answering system or a generative design system or something that generates something new that's based on either transformers or large language models, and I would do that as part of your development. Now, you don't need a team of 50 people. This stuff is open source. It's generally available in one form or another, and I would learn that. The other thing to say is these large language models can be essentially fine-tuned. So if you can get a large language model, you can then tune it to your particular problem. The thing's been has been trained on all language, but you're trying to do something in medicine, fine-tune it to medicine. If you do all of that, you'll be in a very strong position for the next 3 or 4 years of this amazing innovation.